Alright guys, welcome back to Algebra 2. This is the second installment for Section 6.1 Combinations and Binomial Theorem. In this video, or next two, we're going to look at the binomial theorem. So, Blaise Pascal, a French mathematician. He was also a physicist, inventor, writer, philosopher, and Catholic theologian. One thing I found in my readings was interesting. He did an argument called Pascal's Wager in philosophy. He presented it during the 17th century. And he argued that humans bet with their lives that God either exists or does not. I found that interesting. All right. So one thing in mathematics is attributed to him is Pascal's triangle. You'll see that it's got a lot of interesting patterns. The peak of it is a 1, and 1s go down the left and right edge. You'll see the values, well, look down, I guess, the right-hand side where the rows are. Row 0 is actually a row. It is that first number at the top. It is a 1. So row 1 consists of a 1 and 1. Row 2 consists of a 1, 2, and 1. Again, you may have seen these in earlier math classes, Pascal's triangle. A lot of interesting patterns. So for instance, in the second row, row 1, if you take and add 1 plus 1, they sum to the number in the next row that is in between, which is a 2. And if you look in row 2, you see a 1, 2, 1. If you add the 1 and 2 right below it, in row 3 is a 3, so the sum of 1 plus 2 is 3. And again, you see other interesting patterns diagonally. You see 1's going down the left, and the next row diagonally going down the left from top to bottom. 1, 2, 3, 4, 5, 6, so consecutive. Look in the third, you see it go from 1 to 3 to 6 to 10 to 15, or skipping 2, skipping 3, skipping 4, skipping 5, or adding those values. Anyway, lots of interesting values that are found there in Pascal's triangle. So I'm going to the other board, and here's Pascal's triangle laid out, exact same triangle, but it's laid out in combinatorics or combinations. So row 1 is a combination of N0, R0. Row 2 is a combination of two combinations. The one on the left is N1, R0, and then N1, R1. These values correspond with the same numbers in Pascal's triangles. This is just using combinations or combinatorics. All right. Let's see if I can